Good morning. Tomorrow, Friday, we have our Illuminate assessment. So today is our last day of review or reteaching. The last thing we're going to reteach today, it's going to be how do we find the distance for line segments when they're on the coordinate plane. That's fancy terminology for if we give you a diagonal line on a graph, kind of like this practice problem or this practice problem, can you apply the Pythagorean theorem to find the distance of these line segments or these diagonal lines when they're sitting on a graph? As you should recall already from a bunch of our work a couple weeks ago in our review yesterday, the Pythagorean theorem, once we have a right triangle, if we know two sides, the Pythagorean theorem allows us to find the third missing side. So we leverage that. We take that by looking at a graph, and we can always create right triangles on a graph. So your job when you pause this video here, problem or part one for the guided problems, they've already kind of set up a triangle for you here. We want to know how long it is from C to D. And this box kind of helps us see the right triangle that we could be creating. So go ahead, pause the video and try to find what is the distance between point C and point D, and you're going to end up rounding your answer to the nearest tenth. So you should pause the video. I'm going to flip to see my whiteboard, and as you're returning from solving the problem, we're going to take a look at how I would solve this problem, see if my answer is the same as the answer that you got to. All right. So what we see here, we're going to take a look at the screen first. We want to know the distance from C to D. I'm going to open that drawing up so we can look a little bit better, and then I'm going to put some work onto the whiteboard over here. This box helps us recognize that if we draw a diagonal line from C to D, that's the distance we're trying to measure. We should see a right triangle that sits right here. And this right triangle, which I'm going to go ahead and draw onto my whiteboard now, there's a bunch of methods we could use to find what are the two legs, the two side lengths that we need to know before we find the distance from C down to D. First thing I could do is I can just count if it's on a graph. 1, 2, 3, 4 units. So I could say it's 4 units across. And the other leg, we go up 1, 2, 3, 4, 5, 6 units. Other methods that we could have used, the coordinates for C. So we'll go ahead and take a look at the coordinates for C right now real quick. Are -3 for X and +4 for Y. We know that the coordinates for point D, +1 for X, we see it's 1 to the right, lines up with X at 1, and -2 for Y. So if I had known that C was -3 and 4, and that D was 1 and -2, I could recognize from -3 to 1, the X change is 4 units, and then the Y change from +4 to -2 is 6 units, and we see that same two legs of 4 and 6, but instead of counting, I just use the coordinates. So we're going to head full screen that whiteboard now. Either way, we know we've got a right triangle, and to find the measure of C to D, we should recognize this is the hypotenuse. The thing we don't know here is our C. And on the graph, we're always going to know A and B because those are the two legs that go straight sideways and straight up and down. So if I'm going to go ahead and solve this problem now, knowing that 6 and 4 are my values for A and B, take our formula A squared plus B squared equals C squared. And hopefully you had plugged in a 4 and a 6 for the A and the B. At that point, just going to go ahead and do the math. 4 squared is 16. 16 squared is 36. That's still equal to C squared. When we combine these two like terms, the two constants, 10 and 30 is 40. 6 and 6 is 12. 40 and 12 makes 52. That's equal to C squared. What is our last step? Always for the Pythagorean theorem, or whenever we're solving these x squared or c squared equations, the square root is the inverse operation of squared. The square root of c squared is just c. Everything I do to one side of the equation has to happen to the other side, so the value here is the square root of 52. By now, hopefully you recognize that's not a perfect square root, but the square root of 49 is equal to 7, so I know when I put this square root into a calculator, square root of 52 should be just a little bit above 7. That's what we see with 7.211 and the dots indicate it's an irrational number that continues to go on. Taking it back to the guided problems, our answer here, and you should have a whiteboard that followed along with me, your answer here should be 7.2, because that's what happens when we round 7.211 to the nearest tenth. Pause the video, take a look, try to find the distance from point F to point G. This time they've asked you to round or estimate to the nearest unit. As you're doing that out, the video should be paused. I'm going to show a new whiteboard. Now that you've worked on the problem on your own, pause the video. I'll show you how I would have completed that part. The second layer of challenge for this part here, they haven't drawn a box already, but we have a few options. Option one would be to go ahead and create our own right triangle. You could draw onto this with your marker. You could try to go ahead and draw in lines digitally like this, but I'm going to show you a quicker way to do it, I think. I know F, the coordinates for F, are -6 for X, +8 for Y. Lines up with -6 on the X-axis, +8 on the Y-axis. I'm going to write that down on my whiteboard. Coordinates for point F, -6 and 8. Point G, what are the coordinates? For point G, our coordinates, it lines up with 4 for the X value, lines up with 4 on the X, and it lines up with -3 on the Y. So G is 4, -3. I'm going to go ahead and full screen the whiteboard because now I have all the info I need to know the distance from F to G. There's going to be a right triangle here. This is the X coordinate. It goes from -6 to +4. That's how much we change sideways. -6 to +4, I go up by 6 to get to 0, 4 more to get to 4, 6 and 4 makes 10. So I know on that graph I would have had to move sideways by 10 units if X went from -6 to 4. Up and down would be represented by the Y change. I go from +8 to -3. That's down by 8, down by 3 more. 8 and 3 together makes 11. So now we know for this one, the distances are 10 and 11. At that point, it's just a matter of plugging that into a squared plus b squared equals c squared. Whenever we're doing distance on a coordinate plane, we're always finding the diagonal line. We're always trying to find c. So we know a is 11, b is 10. We're going to square both of those. 121 plus 100. That gives us 221. At each step of the way, that was equal to c squared. We know the last step is to take the square root. So c is going to be equal to the square root of 221. I know 225 is from 15 times 15, so this answer, 221 square root, should be just a little under 15. 14.866. And that decimal continues. Rounding to the nearest unit. 14.866, the nearest unit is 14 right here, but the 0.8 tells us we need to round up to 15. So we would say approximately 15 units. That little symbol right here, and I'm highlighting, that shows us approximately 15 units, so that we've rounded off to the nearest unit. Put an image of your work in, let me know, or let Miss Stewart know, or a neighbor know if you've got any questions, and that's pretty much what the work is the rest of the day.